Hello class, this is a video tutorial on further differential equations part 2. In this video, we'll be looking at the gradients of relations using implicit differentiation. As seen in the previous video, implicit differentiation resulted in derivatives of relations involving x and or y as variables. Therefore, to find the gradient of a relation, it requires an input of x and or y. So we'll be looking at finding the gradient of a curve at a point of these relations, which, by the way, these ones will be the exact same 6 that we've already differentiated in the previous video. All we will be looking at is how to find the gradient at the point given. Okay, so here's the first two. You can pause and give these a go at any time you like. Here are the next two, and here are the final two. You'll see why in a moment why the graph of each relation or function has been provided. Alright, so let's get straight to it. Okay, so in order to find the gradient at this point x, notice how this derivative actually has a function, as an expression involving y. So what we actually need is the y value where this is provided. So we need to solve for so y squared equals 5 plus 4. I'm actually just substituting this into our given equation. And solving this becomes 9. Taking the square root, we actually get plus and minus 3. Notice how we will actually get two different gradients for this. So we get dy on dx. When we substitute positive 3, we get 1 on 6, or dy on dx equals negative 1 on 6. So the gradient, we'll just write it as y prime. The gradient y prime at x equals 5 is actually equal to plus and minus 6. Now I'll demonstrate to you using the graph why this is the case. I've actually indicated approximately where square root 5 might be. So it's actually something like this. But notice how at x square root 5, so this point is x equals square root 5. It actually, not square root 5, sorry, x equals 5. It intersects the relation at 2 points, one here and one here. The reason why we have two gradients at this point is exactly because at x equals 5, we actually have two tangents that can be drawn. One here and the other here. Not really accurately drawn, but I think you get the idea. From this, we can conclude that the gradient of this one is positive 1/6, and the gradient of this is negative 1/6. Hence why we have two different gradients at the point x equals 5. Okay, so hope that gave you an idea of how we might solve these now. Alright, so you can pause and give these a go. Now that you've seen this, you can really see that we need a y input. Okay, so now let's take a look at for this one. Notice how for this we have an x input and a y input. From this we can see that we need the y value or values at x equals square root 5. I've drawn it here. This is about square root 5. And notice how there are two tangents at this point. Hence why we have two different results for y. So solving this, substituting square root 5 here, we get 5 plus y squared equals 9. We get y y squared equals 4. So y is equal to plus and minus 2. So substituting 5 for both of them, well, actually, to really get the point across, this point here is square root 5 2, and this point here underneath is square root 5 negative 2. And we are looking for the tangent at both points. So this tangent and this tangent. Okay, so now substituting it, dy on dx, we get negative square root 5 on positive 2, and dy on dx equals negative square root 5 on negative 2. So we're substituting both of them, and for this we substitute square root 5 for both values. So therefore dy on dx equals plus and minus square root 5 on 2, and x equals square root 5. So the gradients of these are positive square root 5 on 2 and negative square root 5 on 2. Alright, so that concludes the first two examples. You can pause and give the remaining a go yourself. And yeah, I hope to see you in the next video. So best of luck.